All right, let's pack up our quizzes and get our dividers put away. And here we go. You're not going to believe this. We are going to practice for another quiz. So, the last few days, we have learned a bunch of new stuff. So today, we're going to review all that new stuff. And we're not going to be surprised if some of these are no solution, right? Because there are rules about how we add and multiply matrices. Did everybody get paper? All right, so let's take a look at this and see. All right. I'm going to skip number 1 for a second because we still have a couple people with their quizzes out there. So I'm going to go to 2, and we'll come back and get number 1 in a minute. Problem A, 2A, I'm on number 2, practice quiz, number 2. B, little b, sub 2, 1. What does that mean? In matrix B, second row, first column. So what number is that? 2. That's a 2. What are the dimensions of matrix A? 2 by 3, right? 2 by 3. Letter C. What is A plus C? Can't do it. Why can't we add those? They're not the same size, right? They don't have the same dimensions. So that's an empty set. A times B. All right, we spent a lot of time multiplying yesterday. So A is this matrix, and B is this one. Can they be multiplied? Is it a doable problem? Well, what are the dimensions of A? 2 by 3. Look, 2, 3. And then B is a 3 by 3. Can those be multiplied? Yes. And the answer will be a 2 by 3. So 2 rows and 3 columns. All right. And you don't have to wait for me. We did a lot of this yesterday. Most of you, I think, had a grip on it. I'm going to go ahead and do it up here, but you go ahead and do it. Remember, if we want this number right here, we're going to multiply the first row and first column. So we're going to multiply row 1 times column 1. So row 1 numbers, column 1 numbers, and it is always row from the first matrix, column from the second matrix. Did you guys get 16? Okay. Now you can ignore me and move on. Some of you are really fast at this. Now I'm going to do row 1, column 2. So row 1 numbers and column 2 numbers. I got -6. Anybody else get -6?
Yep.
All right. Does anyone want me to talk through all this, or you want to just go ahead and do it? Can you do it? All right, let's all do it and see what we come up with. I'm sure I probably have one up there. We're going to church as a class, so I'm trying to find our seating chart. Okay, how do my numbers look? We matching or not matching? Most says we're good. Is there anyone who has a question about a number, like you got them all, but you didn't get 9? Everybody's got this?
Yep.
All right, determinant of A. Now the determinant, that's the thing with the vertical bars that we talked about yesterday. This is a trick question. You may have missed something I said yesterday. In order to have a determinant, the matrix has to be square. So can A have a determinant? No, no answer. Can B have a determinant? Yes. So now we gotta remember how to find the determinant of a 3 by 3 matrix. Does anyone remember that from yesterday?
We have to add the first and second.
Okay, so we rewrite the first 2 columns outside the determinant. So we've got 1, 1, negative 1, 2, 0, 1, 3, negative 1, 5. We're gonna write our determinant. Okay? Here we go. Start here. No negotiation. This is where we start. Start with the first number you wrote down. That guy right there. So we're going to multiply and get
0,
wow,
0,
wow,
0,
wow.
0, 0, 0, 0,
When there's a
0,
0 in there, you're always going to get 0. So that's a 0. And we'll multiply these and get 3. And then we'll multiply these and get, watch your signs, positive 2.
Yep.
And then we add all those up. So our total in that direction is 5. Right? Now we start over this way. What's that diagonal? 0. What's this diagonal? Negative 1. And this one is 10. So in that direction, we have a total of 9. Now what do we do with the 5 and the 9? Subtract. And we subtract in that order. 5 minus 9. This is where you start. Those come first. So that gave me 5. These gave me 9. 5 minus 9. The answer to the problem is negative 4. C inverse. This, I think, is the last thing we talked about yesterday.
Yep.
How do we find C inverse? It's a 2-step problem,
You start from the top.
right? 2-step problem. So we start by finding the determinant. So the determinant is 3 minus 5. Remember, these are multiplied, that's a positive. So it's 3 minus 5. So that's negative 2. We good? Then what do? We make a new matrix by taking these two and and switching places, and taking these two and changing their signs. So that's a negative, it becomes a positive, that's a negative, it becomes a positive. And then we take every one of these numbers, our actual inverse is going to be 3 over negative 2, 1 over negative 2, 5 over negative 2, and 1 over negative 2. Remember, a lot, not this time, but a lot of times that will reduce, something in there will reduce. So if it does, you need to do it. So we're finished. Okay? Now, on the back side is just more practice. Okay? So let's do this more practice. B times A. Oh, we haven't done number 1 either. Remember, I had number 1. B times A. Is B times A possible? I'm on letter H on the back side. What are the dimensions of B? B's are 3 by 3. What are the dimensions of A? Okay, can I multiply a 3 by 3 times a 2 by 3? No! Guys, what has to match when I multiply? These have to match. That's the rule for multiplying. Do they match? No. So therefore, problem H is not possible. Yes. In fact, we already do that. Yeah, we did that on the other side. All right. What about I? What does this mean? 2A. Exactly. So that it's a really easy problem. We don't need to be frightened by it at all. It's really easy. It's going to be, we're going to take 2 times A, so negative 2, 2, 10, and 6, 0, 4. That's all there is to it. That is super simple. Now, what about 2A minus C? What do I do with that? 2A minus C. So I'm going to take this guy. This is 2A. And I'm going to, oh, wait a second. Can I do that? No, because they're not the same size. So that problem J isn't possible either. K, can I find the determinant of C? Yes. And to find the determinant of a 2 by 2, we did one already, it's easy. We just multiply these and get 3. And we multiply these and get 5. And subtract. So the determinant of C is negative 2. And then A inverse. Can I find the inverse of A? No. Another trick question. What is the first step to finding an inverse? Find the determinant. And if it's not square, you can't find the determinant, so therefore you can't find the inverse. So L is no answer. All right, let's go back and do number 1 real quick. 3. Notice it just says solve. What does that mean? Do it however you want. So when I look at this, I don't know, what do you think when you look at it? I always think elimination because that is my favorite. But could I do, I'll see you after school.
Yeah.
Could I do substitution? Sure. If I did substitution, I would probably get this one by itself. But I'm going to eliminate because I like that best. That's what Cam said. So I'm going to have 3x minus 2y equals 11. That's my top one. And then I'll multiply by 2. And add. 14x equals 39. So it looks like x is gonna equal 3. Did you remember on your quiz to write your answers as ordered pairs? So x is 3. And then I'll go back and plug in somewhere. So 9 minus 2y equals 11. I put 3 in right here for x. So negative 2y equals 2. I noticed in homework, some of you aren't careful when you go to subtract your 9. That's a negative 2y. So when I divide, I'm actually going to get a negative 1. Right? Okay, so tomorrow we'll take another quiz. It'll be longer than today's because it has more questions. But some of the questions will not be possible. So you gotta make sure you're paying attention. Okay? So what kinds of things aren't possible? You can only add and subtract if they are exactly the same size. So a 2x4 and a 2x4 can be added or subtracted. You can only multiply when the middle dimensions match up. So if you had a 5x8 and an 8x2, you can multiply, right? If you're gonna find a determinant, that's the vertical bars, a determinant, the matrix has to be squared. If you're gonna find an inverse, it has to be squared. Right? Okay, get your calculators out. We're gonna do something fun today. Learn how to use our calculators a little bit. When we go to church, our seats are in section B, so that's over kind of like in the freshman area, section B, and we are in the 4th and the 5th from the top, okay? So we're section B, 4th and 5th from the top. And we are sitting together. Please don't ruin maths for me by me having to track you down. Let's just go and sit together. All right, here we go. Look at this, my friends. This is a bigger system of equations. So you just took a quiz where you had 2 equations and 2 variables. This now is 3 equations and 3 variables. Could we use substitution and elimination to do this problem? We absolutely could. But we're gonna let our calculator do it for us. So here's what we do. Right here where my finger is, right here, you see the word matrix? It's written above a button. It's written above your inverse button. Everybody see it? Okay. So we're going to go into second matrix. And it pulls up. It says names, math, edit. Everybody see that? When we are going to put data into our calculator, we are going to be in edit mode. So we need to go over to edit. Okay? Now, I want you just to stop right there for a minute because I'm going to show you the matrix we're going to put in. Write this down on your paper. This is the matrix that you're going to put in. You are not going to show any work. You're going to write down the matrix that goes in, and then you're going to write down the matrix that comes out. You are not going to have to do anything except press some buttons. So the matrix that we're putting in is 1, 1, negative 1, 2. See what I'm doing? Where'd those numbers come from? 1, 1, negative 1, 2. So guess what my next row is gonna be? We're not putting it in the matrix yet, we're gonna do that in a minute. 2, -1, 3, 14, and 3, 1,
Oh, yeah,
1,
yeah,
14. Now, can everybody, I give you this problem, can you produce the matrix? Okay, now we're going to put it into our calculator. So, when you press edit, and then A, I don't know, my top one's A, is your top one A? Okay. The very first thing the calculator wants to know, the cursor's flashing up here in the corner, it wants to know, okay, how big is matrix A? So what are the dimensions of this matrix?
3 by 4.
3 by 4, so that's what you put in, 3 by 4. And then it sets up a matrix for you on spaces with that many spots. So start typing your numbers in. 1, 1, pay attention to which direction it's going so you know where to put the numbers. Alright, and then we get the last one in and you press enter. Pause for a second, let's let everybody catch up. Is everybody figuring out how to get the numbers in?
How do I type in for you, like, do I just do 3
No, the calculator does that for you. All you have to do is type here. All right, does everybody have your matrix set up? Okay, now, quit. So hit second quit. We just want to get out of that. We're done putting in data, so we're just getting out. All right, so we're back to our home screen, whatever you had on there. All right, now go back into matrix, so back into the matrix mode. And this time, click over to math. Because a minute ago, we were putting in data, that's an edit. Once the data's in and we wanted to do something with it, then we use math. Lots of options. Go all the way down until you get to the button or the item that says RREF. That's the button you want. So it's a ways down there, just keep going.
Is REF the same?
RREF. RREF. You can REF it, but you're gonna have to do some math on your own. Let's just RREF it, and that will take care of everything for us. RREF stands for Reduced Row Echelon Form, and you'll see what that means in a minute. Okay, so everybody find RREF?
Yep.
Press enter. Okay, now up on your screen it should say RREF parentheses.
Yep.
Okay, now go back to matrix one more time, second matrix. And now we're going to use names. So just press enter. A is highlighted, just press enter. So now on the screen it should say RREFA. Press enter again, and you're going to get a new matrix. And the matrix is going to look like this.
Can you go over that again?
Nope. We're going to finish this problem and then we'll do another one. Probably if you sat up, sat up, you'd be a little bit more alert. No, just wait. I'm not going to confuse everyone else. We're going to finish this problem and then we're going to do another one. Okay? We'll do it exactly the same way. So those of you that are with the program here, this is the matrix that came out, hopefully. Anybody get this?
Yep.
Okay. Now, what does that mean? Well, remember, when you put the original numbers in, this was the X, this was the Y, this was the Z, there was an equals there, and then these were the equals numbers. So what does this say? Everything's the same. This says 1x equals 4. So in other words, x equals 4. It says 1y equals 0, and 1z equals 2. So the answer to the system is 402. So if you did substitution elimination, you would get x equals 4, y equals 0, and z equals 2. All right, let's try another one.
Do we have to close the parentheses?
No. No. If, in general, if it's the last thing you're doing, you never have to close the parentheses. If you were gonna put more in, you would need to. All right, I'm not gonna write down the problem this time because we're about out of time and I wanna get through another example. So for problem number 2, what would our matrix look like for problem number 2, the one we're putting in? It's gonna be 1, 4, negative 2, 0.
Yeah.
2, 1, 1, 6, and negative 3, 3, negative 5, negative 13. Now, don't make a mistake with those numbers, because that will throw off your answer. Does that look okay?
Yeah.
All right. So now I'm gonna go to matrix. So second matrix. I'm gonna click over to edit and press enter. I don't need the old matrix A, so I'm just gonna type over it. Doesn't matter. First thing it wants to know is how big is your matrix? Well, this one is the same size as the last one. So I'll just 3, 4, okay. And now let's type these numbers in on our calculator. So 1, make sure you're using your negative button and not the subtraction button. Make sure you're using your negative button when you type in those negative numbers. Okay, do we have them all in? As soon as we get them all in, we put in that negative 13 and press enter. Then we're gonna quit. So second, quit. That takes us out of matrix mode. Because I need to get out of edit mode. Now I'm gonna go back into matrix, so second matrix. And where do I go now? I'm back in matrix, I
You go
go
to
over to
math.
so I click over to math.
You go all the way down.
And I go all the way down, arrow all the way down till you get to RREF.
Second matrix.
Press enter,
Second.
and then back into matrix, second matrix. A, it's already highlighted, A, enter, second matrix, enter, and then enter again, and it's gonna produce
1, 2.
you RREF, and it produced this matrix. 3, negative 0.5, and 0.5, is that what you got?
Yeah.
So what does that mean the answer to the question is? 3, negative 0.5, and 0.5. Remember how on your quiz, your answer was always an ordered pair, x comma y?
Yeah.
Well, now it's an ordered triple, x, y, z. And they're right in order, x, y, z. And the order of the equation, x, y, z. Okay.
How do you
Why don't you, we have a couple minutes, why don't you see if you can get started on question 3, and we will continue it tomorrow.
Okay, I got it.
Yes. So Seth is working ahead a little bit, and he's looked at or problem number 3. What do you notice about the middle equation? There's no y, so guess what you do? You put a 0 in the y spot. Everything has to be lined up. So you put a 0 in the y spot if the y is missing. Did you at least get a matrix written for the problem? So tomorrow we'll just start by typing it in and seeing what we come up with. Let's go ahead and get packed up. Could you put everything in your backpack, please? Because you know how it is, sometimes other kids start coming in and I don't want anything to come up missing. So go ahead and put everything in your backpack. Yeah.